An exciting set of panel discussions are now lined up for you all. Starting with the talk of the town, 5G. Why do we keep talking about 5G? How soon will 5G be ready in India? Does 5G excite all walks of life? How fast my internet access will be in 5G? What are the new user cases for 5G? Where can I get my 5G phone? Does 5G use more energy than previous generations? Does 5G pose a health risk? What are the challenges faced by the test instrument companies while delivering solutions to 5G ecosystem? Does 5G provide coverage everywhere? Will crowdsourcing play a role in 5G networks? Will 5G lead to more cyber risk? Do the above questions intrigue your mind? Let's hear from the experts on the panel discussion. 5G ecosystem from bandwidth to planned width. We are thrilled and privileged to host Patrick Montague-Jones, Senior Consultant, STL Partners, as our moderator for this session. John Abbott, Technologies Director, Strategic Clients, EMEA for Vertiv. Ajit Kumar Chaturvedi, Director, Indian Institute of Technology, Roorkee, and Vibhu Vivek, Senior Vice President, Products, Cambium Networks. Over to you, Patrick.
Thank you very much, Manjeer. Hello, everyone. Welcome to this session on the next session on the Powering Cloud track. As Manjeer alluded to already, there are many questions that surround the relatively nascent area of 5G. India is right at the beginning of its 5G journey, with pilots already being rolled out in both non-standalone and standalone rollouts. And the Indian government has approved 5Gi as a technology using low-frequency spectrum to boost signal and boost coverage. So I'm joined by an expert panel here, and we've got a few questions to walk through, and I'm excited to hear their opinion on it. So first, I'll turn to Professor Chaturvedi. So Ajit, with the arrival and progression of 5G networks in India, from an academic perspective, what do you see as being the challenges in preparing engineers who will eventually help to operate and run these technologies?
Thank you, Patrick.
Yeah, we can hear you. Thank you.
Yeah, so to put this question in right perspective, let me take 30 seconds to explain what is meant by a new generation of wireless technology. So we have heard about 3G, then we heard about 4G, and now we are talking about 5G. So what is it that changes, that defines a new generation? So the best way to understand is that suppose we talk of the heart of a human being. What is the volume of blood that it can pump per minute? Now, if we say that it can pump, say, half a liter per minute, if we multiply that by, say, 10 times, that means can we get a heart which can pump 10 times the rate as it is pumping now? So that is the kind of change that the technology has to undergo in terms of providing bandwidth, in terms of providing capacity, in terms of providing latency to the users and the applications. So what happens is that there are some parts of the technology which undergo an evolution, but there is a fundamental core that undergoes a revolution. So this revolution happens to what is known as the physical layer. So every wireless technology has a underlying physical layer that drives that powers the enhanced bandwidth, capacity, lower latency. Everything is powered by that enhanced bandwidth. And that in turn is coming from a new physical layer. So that is the very exciting part whenever a new generation is defined, that what is the physical layer for this wireless technology. And naturally, this physical layer is not designed in a day or a week or even in a few months. It takes years and years to come to that standard. And academia keeps on learning or keeps on contributing to this physical layer building blocks incrementally till a standard gets defined. So to second perspective that I would like to bring to the audience is that when you look at the networks on the ground, these networks, they do not change overnight. So for example, as 5G is beginning to roll out, 4G will coexist, and at many places, even 3G will exist. So it is possible that multiple generations of networks will continue to coexist and provide services to the users. Second thing that we need to understand is that all these generations, 3G, 4G, 5G, they have a lot of things which are common. That means which are not changing. And there are several things that change. So to be able to convey this to the two broad communities that academia is concerned with, one is the student community and the other is the professional community. Because this rollout cannot happen unless engineers appreciate what is new, what is different, and how to make a creative use of what is different, and how to be able to engineer new solutions, or how to roll out a network in a defect-free fashion. On the other hand, in the case of the curriculum, what happens is that we have a more challenging task, that we have to explain to the students that why this new technology was improved, why it is able to give a higher bandwidth, and what was the experience from the previous generation. So we must appreciate the experience of 3G, the experience of 4G, to be able to explain to the student community, which is the professional engineers. In a year or two, they become professional engineers, that why we have come up with this technology, with this physical layer, and why it provides a higher capacity, why it provides a lower latency, why it is able to serve more number of users, why it is able to provide higher data rate. So that means it has to be compared with the existing technology. It has to be put in perspective with existing technology. And we have to explain the rationale that why it is happening this way. So these challenges are quite exciting. Last point I want to make is that you cannot teach all these, or you cannot convey all these things to the engineers or to the students unless you have the ability to remove some of the things from the earlier technology. That means whatever curriculum is there, in that curriculum, we have to do a replacement job. Some parts have to be removed and some new parts have to be brought in to be able to carry out this task. So I will conclude in this round here. Thank you, Patrick.
Thank you, Ajit. Super interesting. Of course, yeah, many challenges in terms of being able to get people ready to, I guess, run the race of 5G. But obviously, once people are trained and ready, once engineers are ready to start deploying and running the networks, of course, the next challenge is to scale. So turning to John now, when do you see 5G hitting truly national scale in terms of population coverage, rather than maybe geographical coverage? And have you seen any indicators out there that would suggest kind of back up your hypothesis?
Right, thanks, Patrick. The first, to Ajit, fantastic. It's really nice to see another pragmatist on the panel, which is really important that we remain grounded when we're looking at, as you say, evolution and revolution simultaneously. The short answer to your question, Patrick, is maybe late 2022, perhaps early 2023. But that's the short answer. That's the easy answer. So that comes with some caveats, of course. In terms of indicators, well, where are we now? We know that the 5G trials have started. It started in June in 5 cities: Hyderabad, Delhi, Mumbai, Kolkata, Bangalore. But these are all low-band trials. So of the 3 bands that we have, these are all just based on the lowest frequency, the low band. So from a consumer or a end user experience point of view, we won't see a sort of significant improvement until we see a mid-band launch. And the auction for that for India is planned for Q1 2022. So we have to wait until we really see some improvement. In the background, the operators are, of course, monitoring other markets, perhaps more mature markets, for those seeking for those early use cases outside that of CDN, just straightforward content delivery, faster video or higher resolution video, things like that, which is really just the functionality that we see today just improved. But we have to remember that we're talking about a 5G era. So it's more than just a new radio technology. We're talking about an entire network transformation. So as Ajit said, or I think yourself, Patrick, the operators are going to need to consider a standalone core to be able to distribute that network fully and capitalize, better on the latency and speed increase. So it's mid-band and high-band that are going to see those more advanced use cases. But from where I stand, from the physical infrastructure point of view, the network is going to need to be repurposed and largely re-engineered to become more suitable, let's say, for a cloud native environment, which is the direction that we're moving, right? So where and how the physical environment is maintained, from my point of view, it is an important topic, but it's only one in a sea of challenges that we see in front of us. Because the transformation really works in terms of project terms. One project just rolls into the next. This is continuous development as it rolls along. So to refer back, if I said late 2022 for a baseline of a commercially available 5G functionality, this is what the US would call 5G vanilla. It's really the minimum standard that you can really badge and launch and market as 5G. But I think from a consumer point of view, we're not going to be wowed with a huge increase in performance. But the entire ecosystem of application development and network construction, and of course monetization, probably most importantly, will significantly mature between now and 2025 as everything lifts in parallel. So a launch 2022, but something tangible that we can say, okay, it'll be in incremental steps, but we'll see it by 2025.
Yeah, absolutely makes sense. Thank you, John. Now, in terms of next steps, there's obviously been a history of IT and technology development expertise in India. So I guess in that light, what role do you believe, Vibhu, that India's homegrown hardware and network function companies have to play in the Indian national rollout of 5G?
Thanks. I think India has a lot of role to play, particularly in the given geopolitical situation, the sentiments against China, not only in India. I think India can play a role across the world. And 5G is a very ripe technology to avail that opportunity. Until now, if you look at the GPP stacks, Indian vendors were very good in creating GPPs, 3GPP stacks, or many other stacks, but they never created the product, or products weren't as popular if they were created. And now it's time to do that, to create products. Now, having said that, and having some personal experience with manufacturing in India, there is definitely a lot of improvement, but still a lot to do. And the infrastructure has to be built. So in that regards, there is always very interesting when, the smaller high volume devices are always very, more lucrative to work on, but it is also more challenging. Like if you are thinking about 5G products, working on UE looks like, more right thing to do. But it is more challenging. It is going to be more automated, more infrastructure needs to be built, more supply chain challenges are there. I would think that maybe India should start more with the bigger devices, Bs, or where there are fewer getting made. Engineers can manually work on it and then learn as we build more and more infrastructure to build. So manufacturing is one aspect. Second, I think software-wise, now India can learn. US has been ahead in 5G, and India can learn and do things which was not done there, right? Open RAN is now getting ready, right? So leverage that. Also, I think fixed wireless broadband. I think this is the first time 3GPP standards have evolved to cater to fixed wireless broadband needs, right? Which is 5G. Now, if you look at it, it started with a lot of excitement in some of these countries, but it fizzled in US. And the reason is, I think, the deployment model is different, right? 5G cells are going to be smaller. If you're looking for high capacity, you have to go for higher frequency so that you get bigger spectrums. And when you're deploying bigger spectrums, higher frequencies, direction becomes very important. Penetration is less. So you have to have a small cell. So you need, it's not a countrywide rollout. What you need is local engineering. You need a local engineering. And luckily, India has that. If you're deploying in one colony of Bangalore or Mumbai, you have to know which building is there, which is causing shadow wear, right? And then you have to deploy. So that is something India can evolve, develop things with LiDAR technologies, other things, have more granular level maps and things like that, and build something which rest of the world could use. India can take lead in these things, kind of things. And these are software. Which is India's strength. And lastly, I would say government also has to play a role. If 5G has to move ahead, I think it's quite a bit. You will get some advantages in lower frequencies, but real advantage comes when you go to bigger spectrums, right? Bigger spectrums are higher frequencies, bigger spectrums and which is available on higher frequencies. Now, higher frequencies, smaller wavelength means your devices are smaller. You can build large array of antennas. You can do a lot more with technologies, right? So having these spectrums available is important. Now it becomes very expensive, right? One of the promise of 5G is to bring broadband economically everywhere, right? And if that has to happen, then the spectrums needs to be made less expensive and more available. And for that, there is another thing which people are like in the US, CBRS has been very successful. This is a 3.5 gigahertz, which is basically a shared spectrum, right? Which is coordinated shared spectrum. So same spectrum is being used by multiple devices at the same time, but they are being coordinated. So this kind of something which will bring quite a lot of advantages. Secondly, I would say the government can also think of bringing locally licensed, licenses just for a village, just for a campus, right? And this way you can make it less expensive, roll out networks quickly. So what can Indian companies do? Indian companies on manufacturing, I would say manufacture the bigger devices before you manufacture the volume devices. Use newer things, learn from what some of the Western nations have already done, and Open RAN, I would say, is a big thing to leverage. Deployment wise, India can take a lead in the world. 5G technologies needs local engineering, local how to incorporate local geographies into the deployment, and India can lead that. And certainly, government has to play quite a bit of role there as well.
Thank you, Vibhu. Of course, we've seen a lot of rhetoric around the kind of the national rollout about 5G really being kind of India's generation to make a real mark on the mobile market, particularly with statements coming out of the operators Bharti Airtel and Reliance Jio saying that their networks would be made in India. Focusing more on that rather than outsourcing to companies that would be based elsewhere. Thank you. So we have talked about a little bit referring to other markets. So John, Vibhu, if you do have any particular examples that you could share from the markets that you work in, are there any learnings that operators and vendors in India can take from other markets that are maybe a little bit more advanced in their 5G rollout?
I'll go first if you like.
Sure.
I think generically 5G is still in very much a kind of discovery track. That might come across as sounding a little bit unplanned, but it's a discovery track. There's been huge amounts of money paid for spectrum, and they want to capitalize on that as soon as possible. But they need to do that as financially efficiently as possible. So Open RAN is clearly a dominant future for the radio networks. It has to be. but we've already Vibhu, you touched on the geopolitical issues that do exist, and we've seen in sort of recent capture of recent sort of news that the big OEM operators, they've pulled out from the Open RAN forums. Now they're back in, but because so many were perhaps unvetted. So because it's a much bigger vendor landscape for Open RAN. So two things there really. One is that perhaps those vendors do need to be vetted so that we have an even playing field and there's no sort of dilution of the intellectual property from it. But secondly, it would allow that broader range of vendors, and therefore you could build, an India network for India.
Great, thank you.
No point, John. I completely agree. I will actually, Patrick. I would, I'm looking at 5G more from fixed wireless broadband perspective, and I would comment on that. Here is what I have seen. What I am seeing is there was euphoria around 5G, and a lot of talks were that the first use case of 5G is going to be fixed wireless broadband. A lot of big telcos acquired big spectrums and started rolling out. But as I was alluding earlier, it wasn't easy. When you are dealing with higher frequencies, deployments are not challenging, and a local operator could. For a operator which is countrywide, a rollout like that is challenging because you have to work locally. You have to, actually 5G is going to be more and more. If you think about 5G has brought in first time splicing, virtualization kind of thing, right? Slicing of network. 5G has brought URLLC, right? This ultra reliable, low latency things. So a lot of things for private networks. So a lot of local engineering is needed. With the big telcos, they do countrywide rollout, statewide rollout. They operate very differently. Whereas a smaller operator who operate different way. They know the geography. They have the technical horsepower who can go and deal with things locally. So what is happening is those spectrums are getting sold, and now the smaller operators are buying it and deploying it. I've seen customers in Europe doing that. I've seen even in US doing that. So that is something which will happen, and which is, I think, if India can start from there, that would be nice. Doesn't need to be just top telcos. There should be more companies coming up and becoming bigger. And India has done that. I mean, India has done in the past some of the creative things. So.
Great, thank you both. So now, slightly pivoting, John, you've already talked about how 5G can drive use cases. It can enable new use cases and strengthens many existing ones. We've got, in the consumer space, you've got things like immersive experience, AR and VR. In the enterprise space, predictive maintenance, smart city traffic management, perhaps. But obviously, 5G opens up some opportunities in the cloud services in the data center space. Could you potentially comment on what those opportunities might be?
Well, there's a big shift here. So I'll start with a quote made this year from one of the larger co-locators, and that was that they'd spent the last 20 years building data centers and connecting the network to them. And they said that they will spend the next 20 years building the data center within the network. So there's really a lot to unpack there.
Yeah.
Because that one statement, it brings with it a significant change in the physical architecture. So we're talking about smaller, smarter facilities distributed geographically, and effectively brought closer to the access point in the interests of latency and speed, and of course reduce the network traffic over distances. So within that, you know, within my professional role, I get asked a lot, okay, so is this facility 5 kilowatts or 500 kilowatts? And of course, it's both, and it's everything in between. It's the full propagation of the network. And of course, by that now, I'm talking about edge. And you know, what and where we think edge is depends largely on our point of view and our area of expertise. So there's a lot of different answers in there and a lot of different opinions. But if we look at this from the physical landscape point of view, edge is really a continuum. So where we see the network from the point of view of the core to the edge of connectivity, we're eventually going to see the core to the edge of processing capability. And that's really the big change for the data center. So this means, excuse me, that this means building new points of presence, either within the network itself or in close proximity to it. But while we put this in the context of 5G, this strategy applies as much to fixed line as it does to mobile network. So it's just 5G era. It's just part of that kind of hype bubble as it sits at the moment. But it needs to be a collaborative environment. So edge really needs three elements for it to work. It needs a physical location with some connectivity, which they could get from several sources. A structure that provides the working environment, which is the data center itself, if you like, but it's got to be relevant to that location depending on where it's geographically placed. And then the IT stack and everything that comes with it. Of course, that's the segue to the customer and the end use case. So each could be provided from a number of different organizations, but commercially it's that data center who have the opportunity to bring the customer with them. And without the customer, of course, the edge ecosystem is just an academic exercise. So we're in a bit of a chicken and egg situation, but you know, this is how it's always been with the networks. You know, the 3G network, for example, was built before the app economy even existed. You know, so what I'm saying is that the 5G era is very much in its infancy, and we can only really see the possibilities of what applications driven by low latency, machine-to-machine connectivity and geolocation all bundled together can offer the world. But 5G brings with it some immense opportunities to the data center space and to organizations and individuals with you know, vision. We can't necessarily see what they are. We just have suggestions of what they are. And how they're packaged and how they're put together is part of the evolution and revolution process, I think.
Okay, interesting. Thank you, John. Now, obviously, we've talked a little bit already about coverage and scale. I'd be really interested to understand your perspective, Vibhu, on the digital divide in India. So how will 5G contribute to, I guess, bridging that gap of the areas that have traditionally not had so much access to network services? What changes will 5G bring about in that area?
Yeah. So, you know, India has done quite a lot in bringing fiber and connecting various villages through fiber. But the last mile has remained a challenge. And of late, there have been a lot of projects going on deploying Wi-Fi access points across the villages, 3-4 access point in the Gram Panchayat or in the school or in the hospitals, and which covers the village. And that will serve some purpose, but you know, obviously the network will be slow. I mean, it's not going to bring the real broadband there, right? And then people are, especially in COVID, you know, we run a pretty big lab we have a pretty big lab in Bangalore, and a lot of employees actually went back to their hometown or villages and worked from there during the whole year. And they didn't have access. They didn't have broadband to work. And that is something what 5G can do, right? 5G can very quickly bring higher capacity to your home. Now, that's technology by it looks ripe, good. But there is a lot of things needs to happen, which I touched upon earlier. Spectrum needs to be available to bring that high capacity. Now, and a couple of things the rest of the world is doing is shared a spectrum, is locally licensed a spectrum. Those things needs to happen. In India too, even in 60 gigahertz, I think India has not yet, not yet made it unlicensed. And so that is something needs to happen so that it is cost effective to bring high capacity networks to home. I think, again, it need not be the big 5 telcos. Needs, local ISPs will have a significant role to play if these networks need to proliferate quickly, because again, local engineering is needed. So these two things are, I think, very critical in rolling out 5G or using 5Gs to get rid of the digital divide. On technology side, actually, I got the opportunity since Professor Chaturvedi seems to be very much interested in Phi. And I'll tell you this, Ajit, RF Phi engineers are so difficult to find. And I wish it was taught in school. People who know FPGA programming don't understand Phi. People who understand Phi don't understand FPGA. So it's very difficult to find engineers. I mean, you can find people who have worked in lab. It's very difficult to find. And I wish India had more, because just look at Indian towers. I know I'm deviating from a topic, but since we were on a co-panelist, I'll bring it up.
That's totally
look at the towers and look at the density of radios on that tower. There is hardly a space there. Imagine the interference, right? This is a local problem. This is more and more innovation needs to happen in India to avoid those interferences. Smarter antennas, right? But again, finding that talent in India is challenging. I think more and more schools should bring. So as you are gearing up for this, and I'm excited with your interest. Actually, I'm alma mater of IIT Roorkee too. So that will help. In order to roll out 5G more widely in this, more innovation, local innovation needs to happen.
Great. So that seems, Ajit, that you've been set a challenge there by Vibhu to create that level of knowledge and know-how. So I guess leading on from that question, what do you believe that the role of academia really is for 5G networks and beyond? I mean, even before we started this session, we were talking, and you said, the kind of the research phase for 5G is done. We're now almost moving on to 6G already. What is that role of academia for 5G networks and beyond?
Yeah, let me first partly address the point that Vibhu made. Very interesting point Vibhu made. I agree with Vibhu that there is a huge scarcity in India of RF engineers. But Vibhu, we don't look at Phi as RF. Phi is pre-RF. So we don't have, I don't think we have scarcity of Phi engineers who understand the Phi layer. But I agree with you that RF is definitely an RF engineering. Clearly, what Vibhu said points out that we need to work more closely. We probably need to do more interesting things together with the industry so that whatever talent exists can be best utilized for the rollout. Now, let me take on Patrick's question. So I'll give a very brief historical background here. See, when we were in 1995, we had heard about this term called FPLMTS. I mean, most people may not remember it if they had heard it. Or later on, that term was known as IMT 2000. I think IMT 2000 term, more people had heard about it. So that was the time when we were, we means the technology world, academia researchers, all these people, they were thinking about what was later known as 3G. So even before the word 3G was coined, the physical layer of that, like what will be the waveform, what will be the power control mechanism, what will be the error control coding scheme, what will be the source channel scheme, source coding scheme. So all these things, or very crucially, multiple access technology. So then the word 3G came, and by the time the 3G rollout started, at least in India, naturally we were talking ahead of time in terms of, not at the global level, but in terms of India, I'm saying, that we were already thinking in terms of what should be done for 4G. Now, globally, if you see the research landscape currently, then I think for the last 3 or maybe 4 years, in the academic and research world, there is discussion going on 6G. So, because now 5G rollout is there, so now you cannot come up with 6G in 1 year's time or 2 years' time. It needs 4 or 5 years of research to be able to demonstrate that what will be the new physical layer. And in fact, the target is like 6G networks will be able to use higher frequencies than 5G, provide substantially higher capacity and much lower latency. In fact, to give you some number, one of the goals is to support 1 microsecond latency communications. This is 1,000 times faster than 1 millisecond. And it is expected to facilitate improvements in presence technology, location awareness. Also, with so much advancement in AI, I think the desire is to see how we can incorporate at the very design stage these modern technologies that can be used in conjunction. In terms of data rates, the talk is about 1 terabyte per second. I mean, sometimes it looks very humongous, almost impossible. But then when you think like this, maybe 5 years, 6 years down the line, 7 years down the line, suddenly it becomes possible, especially with the exponential growth in VLSI technology. These things do become feasible. So before VLSI, we are at the design stage. At the design stage, you have to satisfy many constraints. And when those constraints get satisfied, then of course chips get made, and then bigger devices get made, user equipment, infrastructure equipment, and RF front end, all those things happen. But the starting point is the design of that, what I was saying in the beginning, the physical layer. And for that, already work has started. So hopefully in a few years' time, we should be able. Of course, the complex world of standardization has to be addressed, because there are a lot of companies, regulators, countries, all have to put their minds together to come up with a standard. So that will happen over a period of time.
Great. Thank you, Ajit. So essentially what you're saying is academia is always thinking about informing, but always thinking about the next thing. So obviously this panel is about 5G, but there's a million questions whizzing around my head right now about the next generation, and that's absolutely fascinating. So I think we may have time for just one minute, one quick question from the audience. And I'll just quickly pitch it to one of you. So a question is coming from the audience, which says, how will 5G change our daily lives, as consumers? Maybe let's pitch that over the next 3 to 5 years. I'll maybe put that back to Ajit.
So maybe if you ask me an immediate quick answer, maybe the gaming technology will see a very fundamental change, because the low latency application could really take off. But there are multiple myriad ways in which it will make a difference in terms of people who have access to it. But that is in terms of an application I'm saying, but of course downloads will be faster. You can download movies, you can download big files faster. But all depends upon how successful our businesses and government is in providing spectrum, in rolling out the money required, all those things. Those are more difficult questions than academia. So Vibhu and John have a more difficult question to answer than us.
You're absolutely right. Thank you, Ajit. So evidently, on the basis of this panel, there's been a lot of discussion. We're still fairly early on, not just in India, but also globally in the exploration of what 5G can give us. A lot of opportunity to open up new use cases and find out the benefits that we can get from this new technology. I think that's all we have time for on this panel. So thank you very much for joining us in the audience. And John, Vibhu, and Ajit, thank you very much for giving your expertise and your time to hear your opinion. If you choose to stay on with us on the Powering Cloud track, up next is Nigel Gore from Vertiv. Thank you very much all for listening. And if you have any questions, feel free to connect with me on LinkedIn. Thanks very much.
Thank you, Patrick, for this captivating and enthralling session. Thank you, everybody. Thank you, Ajit sir. It's my privilege to know you from IIT Kanpur days.